Hello and welcome to another video from our BeamTool tutorial video series. In this video, we want to show you how we can use BeamTool to design a time of flight diffraction based or ToFD based inspection technique and scan plan. For this example, we want to use a double V symmetric weld in a flat plate with thickness of 19.05 millimeter. If you want to add a ToFD technique or scan plan here, we can go to our probe tab and then choose time of flight diffraction. And by default, BeamTool will locate a pair of conventional probe and wedges on either side of the weld in a transmit, receive, or pitch catch configuration. Now, to specify the specific dimensions or parameters of the probe and wedge that we want to use for this technique, we can go to ToFD probe configuration tab. And here we can either manually basically update the parameters of both probe and wedge, or as usual, load them from the catalog. For this example, I'm going to show you how to load it from the catalog. So here I'm going to load a transducer of C563-SM with 10 megahertz frequency and a 3 meter diameter, which is a round probe, and you see it's going to get updated on the workspace. And then for the wedge, I'm going to use ST1-70L, which is the wedge that creates a nominal 71 to 71.2 degree longitudinal wave. Then after that, the next thing is to finalize the spacing of the wedges. Typically, the option that is chosen for ToFD techniques is to have a crossover point be around 2/3 of a thickness. If you come here to this tab, here we have an option to go to specific crossover depths. Either it can be 20%, 66%, 75%. So here, to be 2/3, which is a common one, we can choose 66%, and BeamTool, knowing the actual thickness is 19.5, will automatically adjust the spacing such that the beam intersection point here be at 2/3 or 66% of the thickness. So if I click on this, now you notice that the spacing of the wedges is now increased, and now the intersection point is at 66%, which is 12.57 millimeter. Here, I'm going to show you then a scan of such plate to show you some of the readings on the BeamTool on the real file. And for that, the spacing which was used, the PCS or from exit point to exit was 71. So I just, for this example, I manually come here and change that to 71 as a PCS. And that kind of shows you that you can also manually adjust that with, and now when I do it 71 millimeter, now you see that my beam intersection point goes to 12 and 0.5 millimeter, which is around 63% also of the thickness. Also, you notice that all these information are here can be turned on and off. So here on the top, if I see this display which position dimensions, you can turn it off, and now all the PCS information or front to front of the wedge are now not annotated. And if I click there again, annotated. The next option here for display crossover dimension, if we click on that, we can turn off that information, but when it turned on, that's the information that shows exactly where our beam crossover point is. And finally, the other one would be the very important information, which is the dead zones on the ToFD. We know that when you design a ToFD technique, you should always be aware of your dead zones. The dead zones are two regions close to the surface and a back wall. On the surface, due to the lateral wave that propagates from right under the surface from the transmitter to receiver, and so the basically a depth equivalent to one full cycle, we will have a dead zone because any indication will get merged into the lateral wave. And BeamTool will estimate that for this configuration or this setup to be 5.62 millimeter. And also on the back wall, similarly, the length of a cycle on the back wall of the A scan gives us a dead zone that indications can merge into, and BeamTool estimate that to be 0.92 millimeter from the backbone. So what this means is BeamTool is telling us that for this setup on this plate, our actual effective, meaningful inspection depth would be somewhere between 5.6 millimeter to around 18 point, basically 18.9 or 18.8 millimeter. So now to just see that, I want to show you the scan of such plate with this configuration. And that's how the ToFD scan of that plate look like. Of course, there are three indications here that I'm not going to go into that at this point. So we know the PCS was 71 millimeter, so we can enter that, and then we can go and calibrate for our time or wedge delay by going to moving our reference cursor to the start of the first negative part of a cycle on the lateral wave, and then when we hit calibrate, that sets are 0 here. Now, if I move my measured cursor right to the past first peak to the second negative cycle, now the distance between these two is read to be around 5.08, which you see it was very close to what BeamTool estimated to be around 5.4. And now also, if I now move this cursor to, let's say, around the first positive cycle of my back wall, you notice that now the distances between these two is read to be 18.95, which again is very close to BeamTool's estimation of being 0.9 millimeter of dead zone from a basically 19.5 millimeter plate. So this is you see how BeamTool's estimate can help us to better understand when we look at our ToF data where our lateral wave and back wall should be and where our dead zones are. And then we can go back to BeamTool and adjust intersection points or PCS or even the angle of the wedge accordingly so that we can get other updated results. I hope that this video was helpful for you. Thank you.